Hi, I'm Mohsen, a certified Microsoft Solutions Architect and Cybersecurity Architect. The purpose of this video is providing advanced security best practices for Azure Storage Accounts. This video provides general guidelines. It's important to evaluate each situation individually. Small to medium enterprises and large businesses with different operational models can benefit from the information of this video. While securing a storage account is crucial, finding the most effective actions can be challenging. This video organizes and highlights the advanced practices informed by years of experiences to provide real security without unnecessary costs. An Azure Storage Account is a service that includes other services such as containers, table, queue, files. We can have unlimited number of containers in one storage account, but be sure that consume the service in an efficient way regarding its purpose. Managing huge number of containers in one storage account might be challenging during security investigations. When evaluating the impact on storage accounts, consider the business criticality of data, size of data, quantity of the services that exist, such as number of containers, etc. Understanding each service of a storage account and use it correctly for the purpose that the service is designed is important. You may use Microsoft well-architected framework and design principle checklists. One important topic that you need to consider is purpose and type of the data saved in a storage account. You shouldn't store sensitive data unencrypted in storage accounts. Use Azure Key Vault to manage your encryption keys and secrets securely. Sensitive data type could be credit card numbers, customer drivers, license details, confidential business documentation, or Azure AD client access token, shared access keys, SAS, SQL connection strings, etc. If you are in a large enterprise and want to check if the storage accounts contain sensitive data unencrypted, you may use Auto Sensitive Data Discovery feature of Defender for Cloud, which I will mention more about it later on part 2 of this video. To uplift the storage account security, the steps would be first, defining the security standards, guardrails, policies, then understanding the current status and having a reporting system, remediation action for existing storage accounts, enforcing policies to prevent deployment of non-compliance resources, and last, improving the procedures and continuous monitoring. I organized the important security configurations of storage accounts in 4 major categories. 1. Access controls. 2. Data loss prevention or DLP. 3. Networking. 4. Logging and monitoring. Disable anonymous read access to containers and blobs at a storage account level. Access controls are the most important part of the security of a storage account. Anonymous read access means read access without authentication or authorization. Containers and blobs in a storage account can have 3 access levels: private, blob, container. When you are creating a new container, you can set the access level permission to one of them. Private means no anonymous access. Blob level permission means anonymous read access for blobs only. Container level means anonymous read access for containers and blobs. The container can be listed and blobs can be read anonymously. Let's investigate an example. I pick up container 3 container which has the anonymous access at container level. I already uploaded 2 txt files or blobs here. test1 file.txt and test2 file.txt. If anyone hits this URL, he can access the test1 file.txt anonymously, can read the file or download it without any authentication or authorization. I opened this URL incognito or private browser to be sure of that. If we take a closer look at the URL, we can see it consists of storage account name, blob.core.windows.net, container name, and file name. Because we set the access at container level, entire container can be listed anonymously. Similar pattern for the URL. Storage account name, blob.core.windows.net, container name, and phrase. You can see that the name of the blobs and their URL addresses are exposed, and we know that each blob or files itself provide the read anonymous access. Now we are aware of the security issue. How can we remediate the storage account? You can set the anonymous access level of each container to private, which could be a huge task, or just disable the anonymous access at a storage account level, which automatically applies to containers. Based on my recent test, your container will still show the access level to blob or container, but in the reality, disabling the anonymous access at the storage account level will apply to them. You can find the relevant setting in configuration section of the storage account on Azure portal, or if you are using Terraform or ARM template, you need to add the line. When you are deploying a storage account, by default, Azure enables the anonymous access at storage account level. You need to explicitly mention in your code or configuration that you want it to be disabled. If you are in a large enterprise and want to remediate the huge number of existing storage accounts to disable the anonymous read access, you can create a custom Azure policy in modify mode and create a remediation task on Azure policy. This can change the configuration and disable the anonymous access at a scale for thousands of storage accounts. To prevent the creation of new non-compliant storage accounts in future, you can enforce a policy in deny mode. The Azure built-in policy is in preview and the name of the policy is not very clear. You can create your own custom policy for this purpose. Then the question is, if we disable anonymous read access, what alternative and secure method should we use? There are two methods. The best method is using role-based access control or RBAC. In scenarios that you cannot use RBAC, the second method is using shared access signature. There are step-by-step guidelines on Microsoft documentation. SAS and storage account access keys are not the same. If you share access keys, whoever has that will have admin access to entire storage accounts. SAS is more secure and provide you more controls such as start date, expiry date, allowed IP addresses, read, write or delete permissions, etc. In part 2 of this video, I will mention more about not using access keys. Security depends on related components. Even you believe that you made your storage account access secure, still there are other aspects that you need to consider. Be sure that your identity and access management is secure and regularly review the roles. Be sure that SAS tokens of storage accounts stored safely in Azure Key Vaults. This example is from a real scenario of attack path analysis that a vulnerable virtual machine that contains the SAS token encrypted on its disk can get compromised and lead to unwanted access to the storage account to the attacker. To prevent lateral movement attacks, see the security as a whole related components. This is the end of part 1 video. In this part, I covered structure of a storage account, solution architecture and purpose of using storage accounts, uplifting storage account security, and access control from important security configuration of storage accounts. In part 2, I will focus on data loss prevention or DLP, networking, logging, and monitoring. Thank you.